AI is moving in unimaginable speed. We have a new AI that completely solves identity drift in video generation. And ByteDance just dropped a major update to their image editor that finally nails text. We have full-sized humanoid robots actually fighting in a ring. And lastly, a tool that turns any boring PDF research paper into a full video presentation.
Santa employs 4 core modules: deep compression AE, linear decoder, only LM encoder, and efficient flow-based training.
Before we start, I appreciate it if you subscribe to my channel and turn the bell on. Okay, this first AI is called SteadyDancer from the Multimedia Computing Group at Nanjing University in Tencent. Basically, what it does is you give it a single photo of a person and a driving video of someone dancing, and bam, SteadyDancer makes your person do that dance while keeping their face and clothes looking exactly like the original photo. It doesn't just warp the image, it preserves the first frame perfectly to keep the identity consistent.
Here we have a source video of a girl in a blue shirt dancing. On the left is the reference image, in the middle is the driving video, and on the right is the result. Look at how it preserves her face. It doesn't just warp the image, it preserves the first frame perfectly to keep the identity consistent.
Now let's look at the receipts. Here we have a comparison. Look at HumanVid on the left. It's jittery. Hypermotion is losing the texture. Now look at Animate. Honestly, Animate is really good at capturing the entirety of the video. The facial expressions, the overall vibe, it might even be better at the whole package. But when it comes to strictly mimicking the dance moves, SteadyDancer is sharper. It locks onto the choreography way better than the rest. This is a bloodbath for the other models. This is wild! We have the Monkey King here. The armor details are insane. Usually, AI struggles with complex outfits like this when they move fast, but SteadyDancer keeps every piece of armor in place while he jumps. It even works on vehicles. Here is a motorcycle riding scene. It uses skeleton tracking to guide the motion, and the bike looks solid, not wobbly like we usually see. It's not just for realism. Here is a stylized game character. The hair physics are reacting to the dance perfectly. And here is a man shoveling snow. Look at the interaction with the shovel. It understands the object he is holding and keeps it consistent. Here's another comparison. Look at mimic motion in the middle. The face gets distorted. Again, looking at Animate, the expression is fantastic. It feels very alive. But if your goal is to have the AI mimic a specific dance perfectly, SteadyDancer is the best at that task. It follows the driving video's motion with way more precision. The identity is locked in. This is fast motion, juggling a soccer ball. The ball physics and the leg movement are perfectly synced. Look at the coat, the cloth physics as she spins. It flows naturally without blending into her legs.
This is intense motion, a guy doing battle ropes. The ropes are moving fast, and the AI keeps up without blurring them into a mess. Here is that ninja style character. The facial expressions are even coming through. Rollerblading through cones. The depth perception here is on point. And here, just a classic dance. The hair flip, look at the hair flip. It doesn't detach from her head. And finally, a cartoon man talking and gesturing. It handles the exaggerated proportions perfectly. One last comparison. Hanging on monkey bars. Look at how the other models stretch the arms weirdly. Animate struggles a bit with the physics here, but SteadyDancer keeps the anatomy correct and the grip tight.
So, how does it pull this off? Let's look at the framework. It's pretty genius. It employs a condition reconciliation mechanism here in the middle. Instead of just blindly following the motion, it looks back at the reference image and reconciles the appearance with the motion data. It creates a loop that constantly checks, does this still look like the original photo, before generating the next frame? That is why the identity stays so sharp. And regarding its availability, if you scroll to the top of the page, you'll see the paper and their GitHub repo. If you click on it, you'll find the page and everything, and it is available on Comfy UI, so I will link these to the description box if you are interested in reading further or maybe even installing it. And the licensing is Apache 2.0 license, which has less restriction, and you can even use this for commercial purposes. To run it locally, you are going to need a decent GPU, likely 24 GB of VRAM or more for the best experience. If there is a Nano Banana Pro update, then we should have a Seedream update also. So ByteDance released Seedream 4.5.
This is their latest and greatest AI image editor. And unlike Seedream 4, this new Seedream 4.5 is extremely good at rendering text. Like the old one was so awful, but wait until you see this. Let's see the demo here. You can see how it removed everything seamlessly. Look at it. It removed everything beside this character. It kept the character in the green outline and deleted the rest. And here it changes into a night scene with a dark blue sky with the moonlight. It is so seamless. The editing is just so good. And here it changes into Chinese characters. You can see it. Look at it. Yeah, here it changes the text into Chinese. Look, it is so seamless. It didn't touch anything else except for the actual text. Here it changes without affecting the model's pose. It just changed this Mercury thing into, something like liquid. It seems liquid, including her hand. The style is so amazing. In terms of style, I think Seedream beats every other image model, including Nano Banana. In here, it changes only the word diction and dictionary into italic. You can see it changing to italic. The precision is insane. And here, it changes it into the top hot sale with the exact price tag that was written in the prompt, and it is seamless.
And this one is crazy. I mean, look at it. I told you that it is good at text rendering, but this goes beyond everything. Look, it created a full process copy design tool for entrepreneur and designer, and it covered all the necessary things from it. Unleash your potential. Look at this interior design. It populated the entire bar. And here, it took these 6 input images of cartoon characters and it combined them into one scene. And it looks seamless, and the characters are actually the exact characters. So this shows you how Seedream 4.5 is consistent. And when you come to aspect ratio, it gave this modern design, and it asked it to generate 6 posters from it. One is 1x1, and the other 2x3, 4x3, 16x9. And it did it wonderfully. And here we have this basketball ball, and within it, there's a basketball court and players. It did prompt it to refer to the creativity of the input image and generate 4 separate images for football, volleyball, golf, and tennis. And voila, it did it amazingly.
And I don't know why, but when it comes to performance, they only compared it with the old Seedream 4.0. It's kind of sad because last time when Seedream 4 beat Nano Banana, they showed off that it beats every image model. But now, since they know Seedream 4.5 doesn't beat Nano Banana Pro, I will say it doesn't even come close. So they only compared it with their old model.
And if you come to lmarena on Text-to-Image Arena, you can see that Seedream 4.5 is in 8th place, with only a 2-point improvement over the previous Seedream 4. So there is not much of a difference. But when you come to Image Editing Arena, you can see that Seedream got a 20-point boost, which is good. But compared to Nano Banana, it just jumped from 1324 to 1409. Like, this is impressive. It is almost a 90-point improvement. Seedream didn't get a huge update like Nano Banana.
And if you want to try it, you just need to head to the chat section and then you're going to click a direct chat. Then normally it's going to be like this. You just select, if it is an image model, you're going to select image model. Automatically it is Gemini 3 Pro, but you just click here and on the dropdown you're going to find Seedream 4.5 here. You click on it and type your text and it's going to generate. And you can also upload an image here to edit it.
But check this specific detail. Here, you can see the leaf. Not only the leaf. The prompt says, replace the pine bonsai on the right with a minimalistic dried branch arrangement, leafless twigs. That means leafless twigs. And it told it the shadow. The shadow must be consistent. And you can see the shadow for the twigs just disappeared. It removed the shadow of the old plant and generated the correct shadow for the thin twigs. It's so marvelous how it did it. Moving on, Unitree's H2 is finally ready to fight. When this thing was released a few months back, it was just walking. But now, look at this. They taught it to box. And for some reason, they're showing it beating up on its own smaller model, the G1. I guess it's one way to show us just how strong it is.
It is impressive. Like, this robot is almost 6 foot. Look at it dodging. It would be helpful if they deploy both the G1 and the H2 in the real world. Maybe in a lab, and especially in households, doing all the chores. It should be better if they do it like that instead of fighting. But I would say it is impressive.
Look at the precision here. It kicks a water bottle off a stand without knocking the stand over. That is some serious control. And boom, a standing backflip.
For a robot this size, that is terrifyingly agile. And next, we have the T800 from Shenzhen EngineAI Robotics. And about this new robot, like there was a video that went viral in social media, this new robot kicking its own CEO.
And yeah, I thought it was interesting for you to see it. People were amazed by it, and some said that he was just acting. But both are correct, like the robot is amazing. Look at this jump kick. This is a full-sized humanoid, 1.73 meters tall, launching itself into the air. Here it is sparring. Now, about that viral clip, notice the way the guy was standing. I mean, if you are going to defend from a kick, you are not going to stand like this. You are asking to get knocked off. One leg should be backward, and you should bend your front leg as if you were trying to block something. But this guy just let the robot knock him. But still, this is like the most powerful robot. I think its power beats the Unitree G1. Look at the flexibility. It's doing shadow boxing. The speed is incredible. That is a high kick. It goes right over the guy's head. And a jump spin kick? Come on, that is martial arts level stuff. Synchronized kicking with a human? It matches the human's timing perfectly. A flying side kick. I mean, do we really need robots that can do flying kicks? Here it is in slow motion. And it can stretch. It's not stiff. The range of motion is very human-like. And just to show it's safe, here it is walking in a park with a child. A little fist bump. Cute, until you remember it can do a flying sidekick. Next up is PhysHSI, created by the team at Intern Robotics. This is a physical world humanoid scene interaction system. Basically, they teach the robot to act like a human in a simulation, and then put that brain into a real robot. Here is the simulation. It's walking while carrying a heavy blue crate. Notice the posture. And here it is in the real world. It walks exactly the same way. It transfers perfectly. It places the crate on a shelf. It uses LiDAR and vision to know exactly where the shelf is. Sitting down is actually really hard for robots because of balance. Here it is in the sim. And bam! In the real world, it approaches the bench, turns around, and sits down just like a person would. Lying down. This requires complex coordination. And in reality, it lies down on the bench without falling off. And getting back up. Here is high knee stepping. And a dinosaur-like walk. Because why not? It shows it can learn any style of locomotion. So how does it work? Let's look at the system overview. It consists of 3 parts. First, data preparation, where they capture human motion. Second, AMP policy training in the simulation, where an adversarial network teaches the robot to mimic that motion while balancing. And third, real-world deployment, where it uses LiDAR and cameras to localize itself and interact with the scene. As you can see, the paper is here listed, and you can even find their video on YouTube, and you can find their code on GitHub. And if you click on it, you will find all their code here listed, how they train each specific task. For example, like we did see in the video, that the carry box example, and the other 5 tasks like getting up, lying down, sitting down, and other 5 tasks. So if you want to read it, I'm going to leave it for you in the description box. Finally, we have paper to video from ShowLab at the National University of Singapore. This tool is a lifesaver for researchers. What it does is it's simple. It takes a research or a scientific paper and a portrait or an image of someone and their voice, maybe a few seconds of voice. And then it generates a full preview, a full video of this guy reviewing the research paper. Here we have this research paper called the Forward Algorithm and the image of Hinton Jeffrey and his voice. It is 12 seconds. Let us hear it.
Just having a few types of Lego block, we've got about 100,000 of them. And each Lego block isn't a rigid shape. The name of the word tells you roughly what shape it is.
Yeah, by combining these 3 things, it generates a 5-minute video of Hinton Jeffrey reviewing the research paper. Let us see the video.
This presentation introduces the forward algorithm and summarizes key investigations. The work is by Geoffrey Hinton, Google Brain. Presented September 18, 2025, we provide an overview of FF motivation, related work methodology, experiments, analysis, and prospects.
Yeah, as you can hear it was his voice, and it created an entire video of him explaining the research paper. Okay, like as you have seen it is doing the paper review nicely. You can see the cursor moving along the thing that this guy says. Not only that it was able to clone his voice, but the lip sync seems real. But here is the catch. When I kept looking on this 5-minute video, I noticed that it just skips the details. Like here, you can see the recurrent network used to process the video.
Using pipelined mechanisms. A schematic illustrates our recurrent network for video processing.
It just mentions it, but doesn't explain the graph.
Per layer and 11x11 receptive fields, Results are summarized in the accompanying table comparing BP and FF.
Same with the table. It mentions the table but doesn't interpret the results. It's basically just reading the report. It would be better if it could explain the images and charts like a vision AI. Let us see another example. Here is the Sana paper from NVIDIA and Jensen Huang's image. We have his audio here to clone.
Incredible graphics card here, Blackwell. We're going to shrink it and put it in there. Does that make any sense? Well, you can't do that without artificial intelligence. And the reason for that is because
Okay, as you can hear it was short, only 12 seconds. Let us see the video.
Sana employs 4-core modules deep compression AE, linear decoder, only LM encoder, and efficient flow-based training. The pipeline uses a 32 AE for compression, linear attention, and mix FF.
You can hear that it cloned Jensen's voice almost perfectly, but the way of talking doesn't seem like Jensen. He sounds like a reporter reading a script. Jensen's natural speech fluctuates. This is too flat. But that's understandable. It didn't train to explain like Jensen, just to clone the voice. Here is one with Jan LeCun. Let's hear the sample.
Maybe is systems that are trained on sufficiently large amounts of data that any question that any reasonable person may ask will find an answer through the systems. And it would feel like you have, a PhD.
Let's see the result.
Here we detail the layer configurations for both large and small models. The convolutional section presents the number of units, kernel size, and pooling configuration across 6 layers. Fully connected layers are specified with unit numbers for both architectures. Final layer size is problem dependent.
Yeah, the voice is wonderful, but look at him. He just doesn't move below his head. Nothing moves. It clearly looks like a picture is talking because his shoulders are frozen. It looks a bit weird, but surprisingly, in this part, it actually tried to explain the table a little bit. And finally, the paper is this actual AI Paper 2 video, referred by Tang Eng Chi. Let us hear his voice.
Get the students to work with you, to learn together. That's important. And you need to have that empathy to be able to understand.
Let us see the video.
Welcome to my talk on Paper 2 video, automatic video generation from scientific papers. This work is from Show Lab at the National University of Singapore.
Yeah, this one feels the most natural out of all the examples. Not only that it cloned the voice perfectly, but you can see a slight movement below his neck. It seems as though he was actually recording while reviewing the paper. So how does it pull this off? Let's look at the Paper Talker framework. It's a multi-agent system. It starts here on the left with the PDF input. Then it goes through 4 builders. First, the slide builder extracts content and creates slides. Second, the subtitle builder creates the script. Third, the cursor builder aligns the cursor with the speech. And finally, the talker builder generates the talking head avatar. All of this happens in parallel to create the final video. And if you scroll back, you can see their paper here in archive, and their dataset, and their code. Let us click the code button. Here is their GitHub repository. They released everything. But here is the warning. Since it takes image and audio and creates slides, speech, and talking head all at once, it's going to demand more than a consumer-grade GPU. They say the minimum GPU requirement is an NVIDIA A6000 with 48 gigabytes of VRAM. This is nuts! It is clear this is not average gaming PC. But if you have the hardware, it's open source under the MIT license. And I think that's it for this video. Which news did you find the most useful? Honestly, seeing the T800 do a flying sidekick was terrifyingly awesome. But paper to video is a literal game changer for researchers. So if you enjoyed this video, consider subscribing and hitting the bell. Until next time, folks.